Okay, welcome to this video. I will do several questions here that are likely to feature in your Kcse exam as far as mathematics is concerned. The first question is coming from a topic we call binomial expansion, and the question reads: find the expansion of 1 minus x over 3 to power 7 in ascending powers of x up to the term in x squared 2 marks. Part B of the same is use the expansion above to find 0.99 to power 7 to 4 significant figures. Okay, so for you to do that question, you need to know how we write down the coefficients, and this is like 7. Okay, a situation where you say n choose x to get the coefficients, and these coefficients are 1, 7, 21, 35, 21, 7, and 1. Okay, so for you to get these coefficients, you can also use your calculator here. You can say 7 choose 0, and that will give you the first entry here. Then you go to 7 choose 1, it gives you the second entry, and so on. Okay, if you do that, then we need to expand this to the power involving x squared. Okay, so for us to do that, we quickly take 1, that is the coefficient, times 1. Okay, so we know it should be from this end, because the power is odd, the last number here should be negative. So you have negative, positive, negative, positive, negative, positive, negative. So this is a negative. Then 7 to the power of x over 3 to the power of 1. Then we know negative goes now to positive because the signs alternate. Then we take the other coefficient, that is 21. Then x over 3 to the power of 2, and that one is the expression that will give us a term involving x to power 2. So we simplify this and we get 1 minus 7 over 3x plus this is 21 x squared over 9, right? Okay, now from here that is the expansion. We cannot proceed because we are told to go up to the term involving that. Exactly. So we now use that expansion down here. We take now 0.99 to the power of 7, and we equate this one to 1 minus x over 3 to the power of 7. And because now the powers are the same, we take the numbers in the parentheses and we equate so that we solve for the value of x. All right, so this gives me minus x over 3. It's 0.99 minus 1. Okay, so this x over 3 should be equal to that number, which is 0.99 minus 1, but of course should be negative. And now because of the sign on the left hand side, make it positive. Multiply by 3 both sides, so x becomes 0.03. Right, now we got the value of x. We now substitute that value into this expansion here. Okay, so we have 1 minus 7 over 3, 0.03 is the value of x, plus 21 over 9, 0.03 x to the power of 2. Okay, so you can take now 1 minus, use your calculator here, 7 over 3 times 0.03, and that gives us 0.07 plus we square first 0.03, then times 21, and then you divide by 9, right? That gives us 0.0021. Okay, so when you simplify, get 1 minus 0.07, then we also add 0.0021, and we get 0.9321. So, and that's the answer to that part. Okay, we go to the next question here. Find the length of dp in the figure below. So dp is here, so we can call this one unknown x. This topic is circles, chords, and tangents. All right, so we have a relationship that says you take the whole length from A to P. So AP you multiply by PB, that should be equal to CP times DP. Okay. All right, so now we take, this is 6 plus 3, 9, 9 times 3, 27. Okay, this is 6 plus 3 to get the whole line AP, that's 9 times 3, 27. 27 should be equal to 8 plus x, right, times, now from here to there we have x, so this gives us a quadratic in x, so we have x squared plus 8x minus 27 is a 0. Okay, so from here, solving this quadratic, we can use the quadratic formula. We have x is equals to minus 8 plus or minus square root of 8 squared minus 4 times 1 times negative 27 all over 2 times 1, and this one gives us first of all take 27 times 4 and we get 108. 108 plus 64 get 172. So here is the square root of 172 divided by 2, and we are going to get okay, so we can square root first, then we minus 8, and then we divide by 2. The other one definitely will be negative. That's why if you square root, then you minus, length cannot be negative, so we stick to the positive one. And so this is the value of x, 2.56. Actually, if you substitute here, it will work, right? Okay, so next question here, given that OA is equals to 3i plus 2j minus 4k, and OB is equals to 4i plus 5j minus 2k, and that P divides AB in the ratio 3 is to negative 2, determine the position vector of P in terms of I, J, and K. Okay, this is an external division of a line, and I'm going to use the ratio theorem, right? Okay, so to make just a simple sketch here, so this is my origin, so I'll locate A there, locate B here, locate P outside, and if you add these two, you're going to get a 1, so it means from here to here we have a 1, and from here we have a 2, so that you go 3, then go back to B 2 units in the opposite direction, hence negative. All right, so the ratio theorem says, like, if you want now OP, you can have n over m plus n of vector A plus m over m plus n vector B. Okay, it's very easy. So I know my A vector it should be 3, 2, and minus 4. My B vector should be 4, 5, and negative 2, right? So I'm just going to take the ratios here, take n. So in this case, this is my m, this is my n. So my n is minus 2 over the sum, which is 1. Then I locate my vector here, plus b is 3, so 3 over 1. Okay, 3, my m is 3, I should say. Then b vector is 4, 5, negative 2. So I now distribute negative 2, I'll get negative 6, negative 4, and 8 here. Then plus 12, 15, and minus 6. Okay, if you add these two, they're going to give us 6. This is 11, and this is 2. Okay, we are supposed to leave our answer in this position vector, so P becomes in fact should be OP should be 6i plus 11j minus should be plus also, plus 2k, right? That makes sense, right? Good. Okay, so we'll stop there. Then in our next video I'll be able to continue and give you an intuition more about the revision. Thank you.